Bright Tuty. Every student matters.
Let us perform another activity. Think of the situations when the object is not displaced in spite of some force acting on it, and the situations when an object gets displaced in the absence of a force acting on it. There are so many times when you feel that something is moving without any particular force, but it's not the case. There is no visible force actually, right? But there must be some force. Whether something is falling, then it is the force of gravity, it may be the force of air, right? Not many other things. So these are the situations that you can think of, and again you can just discuss it with your friends whether in each case some work is being done or not. Clear? Now when we talk about work, we have said that, for example, this is a table. Now this was an object. We have said that some force is being applied, and this particular object, which was initially kept at this particular position, after applying force and under the impact of force, it has been displaced, and now this is its final position, and we relate that this is the distance moved by the object. So both the conditions are fulfilled. In this case, we will say that yes, we have done some work. Got it? Now, this work done is based on two things. One is force and one is displacement or the distance moved by the object. Got it? Now, if I am applying force and the body is moving and covering a distance which is in the direction of the force applied, then we say that it is a positive work done. Now, what is positive work done? Positive work done means work done when force is applied and the object is moving in the direction of force. Try to relate a few cases, few situations where you can see positive work done. For example, kicking the football. The direction in which you will kick the football is going to go in that direction only. That is positive work done, right? Playing badminton or lawn tennis or cricket, anything, wherever you are applying force, then in those games, the object, whether it is a shuttlecock or a lawn tennis ball or a cricket ball, they will go in that direction in which you are actually applying the force. Therefore, we say that it is positive work done, right? You are pulling a drawer out of your table. Now, the direction in which you apply force, the drawer will come out in that direction only. That is positive work done again, right? But there are certain cases when you apply force in one direction, but the object moves in opposite direction. In that case, now the work done is called as negative work done. It is negative work done. What is meant by negative work done? When the force into displacement product is in minus. That means the distance moved by the object is opposite to the direction of force. Now students may ask, sir, how is it possible? If I am applying force in one direction, how can the object go in the opposite direction? It does. There are so many examples. Bow and arrow. What you do is you just pull the bow in your direction, and when the arrow is pulled, then in that case when you leave it, it goes in the opposite direction. Catapult, rubber band, a spring, you compress the spring downwards, when you leave it, it jumps up, right? For example, you are wearing skates and you are applying force on the wall. In that case, what happens is that the moment you apply force on the wall in the forward direction, you go in the opposite, in the backward direction. Those all are the examples of negative work done. Got it? So this is all negative work done. Clear? Another thing is zero work done. When you are applying force but there is no displacement or distance moved by the body, then the work done is said to be zero. Now under this topic, you need to relate one quite important thing, that whenever there is a perpendicular force acting right on an object, fine, perpendicular means that it should be perpendicular to the gravity, fine. For example, I am just carrying a briefcase in my hand and just walking, or I am carrying some briefcase on my head or some luggage on my head and standing, right. In such all cases also the work done is zero. Now, where it is quite important thing is, where it is important, when we talk about the planetary motions of the heavenly bodies, we know that the sun is in the middle, the earth is revolving around the sun in a elliptical orbit, and in this circular motion the earth is always moving in tangent. We all know it, we have studied in gravitation, right, if you recall that. And there is a centripetal force, that is the force of gravity which is acting on this earth, and it is always perpendicular. Because of that perpendicular force, the earth, while it is revolving around the sun, it is actually not doing any work. Similarly, the moon, which is revolving around the earth, it is not doing any work. Got it? So, whenever we are just carrying a briefcase, it is in perpendicular to the ground. Whenever we are carrying a luggage on the head, it is perpendicular to the ground. The earth, it's always the centripetal force, the perpendicular force from the center. In all these cases, there is no work done being done, and that is why it is called as zero work done. So, there are three types of work done as we have discussed, that is positive work done, negative work done, zero work done. Positive work done, when the work is done as the force is applied and the direction is same, the motion of the body is in the same direction as that of the force, that is positive work done. If it is opposite to that direction of the force, then in that case it is negative work done. If it is perpendicular or if there is no distance moved, then it will be zero work done. Clear? Let us try to relate a few things. See, a force of 5 Newton, this is the force, is acting on an object and the object is displaced by a distance of 2 meters in the direction of force, right. So, we have to calculate the work done by that particular force. Now, simply we know that work done is calculated as the product of force and the distance. Simply the force is 5 Newton and the distance is 2 meter, it comes out to be 10. 10 what? The SI unit is joule. So, work done is equal to 10 joule. Got it? Let us see the next case. A force of 7 Newton acts on an object. This is the force and the displacement is 8 meters. This is the displacement given in the direction of the force, right. Now, what is the work done in this case? Once again, as we know that work done is equal to product of force and distance. Force is given to be 7 Newton multiplied by distance moved is 8 meters. So, it comes out to be 56 joule. So, this will be the work done. Clear? Quite simple questions. Let us relate. A porter lifts a luggage of 15 kg from the ground and puts it on its head 1.5 meter above the ground. Calculate the work done by him on the luggage. Now, we know that work done is equal to the product of force and distance moved. The distance moved is basically 1.5 meters, that is given to us, right. But we are not being provided with the value of force. Now, we know that force is also equal to m into a or m into acceleration due to gravity. This is as per second law of motion, and this formula we have related in the gravitation chapter. So, rather than writing force, I can first of all calculate the value. Mass is given to me to be 15 kilogram multiply by the value of g, which is given to me, I am assuming it to be 10 meter per second square, right. So, this comes out to be 150 kilogram meter per second square or 150 Newton. So now I am given the value of force. Putting this value of force 150 Newton here in the formula, I can calculate my work done, which comes out to be 225 joule. Answer. Simple, right? We just need to first of all calculate the value of force. Okay. Now let us see a few more questions. When do we say that work is done? Now we say that work is done when a force produces motion in a particular object, right? Write an expression for the work done when a force is acting on an object in the direction of its placement. So what is the expression of work done? Simply work done is equal to the product of force and distance, where WD is the work done, F is the force and S is the distance moved. I am just saying it verbally, but when you are writing the expression, you actually have to specify where WD is what? Work done, F is what? Force and S is what? It is the distance moved. You need to write it fully, because the examiner is not going to give you full out of full marks in just writing WD is equal to F into S. Simply the question rises as to what F is, what S is. You need to specify. Okay. Define 1 joule of work. We have already seen 1 joule of work will be the work done. Work done is equal to F into S. F was SI unit Newton, S was SI unit meter. So the work done joule, while defining 1 joule, I will say that 1 joule is the work done when 1 Newton of force is applied on an object and moving it by a distance of 1 meter. Clear?